All right, so Foundations 30, this is section 4.3. And we're going to take a look at number 16. Oh, boy. Okay, so 16. So in order to solve a permutation equation, okay, what we want to do is we want to write the permutation out as the expression, as the equation. So, for example, 6PR, we know this over here, that NPR is what? N factorial divided by n minus r factorial, correct? You guys can see that, right? Okay. So let's put the 6 in for n. 6 goes there, and there, and there. Question?
Does it matter if the factorial is in the brackets or?
Oh, it doesn't matter if the factorial is, yeah, it does actually, thank you. It does actually matter if the factorial is in the brackets. That does mean slightly different, so I did mean to put that outside, thank you. So we've got 6 factorial over, now we don't know what r is, so we're going to do 6 minus r factorial equals 30. Okay. So we want to solve for r, and so it would be nice to get r, or at least the expression that r is in, kind of somewhat by itself. So let's multiply both sides by the 6 minus r factorial and divide both sides by 30. So we're going to rearrange this equation a little bit. And we've got 6 factorial divided by 30 then equals 6 minus r factorial. So what is 6 factorial? Well, you can get on your calculator there and figure out what 6 factorial is. And we'll do that here. So 6 factorial, 720 divided by 30 is 24. So 24 equals 6 minus r factorial. Now when you get to this point, you're going to probably be tempted to say, okay, how can I get rid of this factorial operation here? Like what's the opposite of that? What can I do to undo that? And the realization is that there is no opposite operation for factorial. So you can't just get rid of the factorial. So that means that you're going to have to try and write both sides of this equation in terms of a factorial. So you need to focus on 24 and think, okay, is there a way that I can write this as a factorial? And you know what the easy way to do that is? Just run through this in your mind. Go 1 times 2 is 2, times 3 is 6, times 4 is, 24. Look at that. See that? 1 times 2 times 3 times 4. So guess what? 24 is 4 factorial. Now why do we do that? Well, because when we don't have an opposite operation for an operation like the factorial, what you want to do is you want to try and equate two sides of the equation so that you can look at the parts of the equation and focus in on the corresponding parts. So this 4 factorial is equal to 6 minus r factorial. So these are corresponding parts to equal things. So if you have 2 corresponding parts to 2 things that are equal, then you can let those corresponding parts equal each other. This is how we get rid of the factorial, really. So this becomes 4 has to equal 6 minus r in order for the 2 sides to be the same. You see, 4 factorial has to equal 4 factorial. So now it's really easy, isn't it? 6 minus what is 4? Well, r is 2. So that's kind of how you attack these permutation equations, okay? And we'll do B as well, and I might actually just start B and then get you to finish B. But let's take a look at this. So 2 times what? Well, 7PR is going to be 7 factorial over 7 minus r factorial equals 420. Okay. So what about this 2? Well, that's just a regular old multiplier, so let's divide both sides by 2 to get rid of that 2. And this becomes, over here, 210. Okay. And now we just do the same thing that we did before. So I'm going to just give you a minute or two to see if you can solve for r here. Maybe you've done this question already, but just humor me and go from here. I don't know if you did it this way or not, But do it the same way we did A and see what you can get for R. Okay, you should be done giving that a try right now. And so here's what it looks like. You get rid of that 2. And of course, we do the same thing that we did in the last question. You would multiply both sides by 7 minus r factorial, which takes this up there. And you divide both sides by 210, which takes it back down there. 50/40 divided by 210, according to my calculator, is 24, same as A. And so now we have 24, as we know from before, is 4 factorial. So 4 has to equal 7 minus r, and so r here is 3. Okay. Now, state any restrictions on r. Now, that's the second part of this. And of course, we didn't do that for these questions, but what would be the restrictions on r? Well, we know that r has to be less than or equal to 6, or between 1 and 6 for this one, right? And over here, r needs to be, right, if this is going to be 7 pick something, it's going to have to be either 7 pick 7 or all the way down to 7 pick 1. 7 pick 0. I guess 7 pick 0. What's 7 pick 0? Can you do that on your calculator? Do you get an error, or what do you get? 7 pick 0. Okay, so 7 pick 0 or 6 pick 0 is actually technically 1. So you think about that, how many different ways can you arrange 0 items out of 7? Well, there's only one way you can arrange nothing. So it technically, r has to be, less than or equal to, is it? Oh, I hit the button. R has to be less than or equal to, for this B, less than or equal to 7, but also R has to be greater than or equal to 0. So the restrictions, you would write that like this. R is between 0 and 7, and it can include both 0 and 7. So these are the restrictions on R, and of course, R is an element of, what does R have to be an element of? Of what? What did you say? I, yes, yeah, speak up. Speak up. R is an element, well, I know you're probably just unsure. It's like, it's okay. That's what people do, and they're kind of unsure sometimes. It's kind of like, I think the answer is, yeah, that's what I said. That's what I said. Yeah. I'm not saying you did that, but I've seen that 100 times. Yes, that is what you said. I know. Okay, so for this one over here, obviously, this is going to be what? Between 0 and what? 6 over here, right? So less than or equal to, so r is greater than or equal to 0, while at the same time being less than or equal to 6. And r is an element of I, which is integers, okay? So there you go. There's the restrictions, if you want to write it that way. And yeah, anybody have any questions there? Okay, so that's 4.3, number 16.